Last stage we gave the model hands. It can call tools, run an agent loop, speak the OpenMCP standard, but hands make a model dangerous if it is wrong. So before we ship anything, we need 3 gates: measure it, bound it, attack it. This episode is the first gate: measure. And we start with an uncomfortable fact. The benchmark in every launch slide is the one that stopped meaning anything. On-screen hook, the benchmark everyone quotes stopped meaning anything. Spoken callback, we just put the model in a loop with tools. Now we ask the harder question, is it actually correct, and how would we even know? MMLU, GSM8K, Human Eval. For years, these told you which model was smarter. Today, every frontier model scores in the high 80s or 90s on them. So the scores all bunch together and tell you nothing. That is saturation. The field moved on to harder sets, MMLU Pro, GPQA Diamond, built specifically because the old ones got beaten. For open-ended answers, there is no answer key, so we ask a strong model to grade. It works. A GPT-4 class judge agrees with humans about as often as humans agree with each other. But the judge cheats in 3 ways you must correct for. It prefers whichever answer it sees first, it prefers the longer answer, and it prefers answers from its own family. Now RAG. A RAG system fails 2 different ways, and you have to measure them separately. The retriever can fetch the wrong documents, or the generator can ignore the right ones. 4 numbers split the blame: context, precision, and recall grade the retriever, faithfulness and answer relevancy grade the generator. And the failure everyone fears: hallucination. The model is a plausibility machine, not a truth machine, so when it doesn't know, it doesn't stop. It makes up the most fluent sounding answer. There is no single fix. There is a stack. Ground it with real facts. Turn the temperature down. Sample several times and check they agree. Let it abstain and add a self-check pass. Offline scores prove a model can be good. Only a real A/B test proves a change is better. Design it before you run it. Split users at random into control and treatment. Pick your one primary metric in advance. Fix the sample size from a power calculation, so you can't peak and stop early. Keep a holdout and only ship if the lift clears P less than 0.05. And when a metric and a human disagree, don't stare at the metric. Slice the eval set by language, length, and topic to find the broken cohort, and rule out the 3 silent killers: a benchmark whose answers leaked into training, an eval that tokenizes differently than serving, and a harness you can reproduce. Here is the picture that ties eval together, one chart. On the left, the saturation curve. On the right, the 2x2 that tells you who to blame in a broken RAG system. Same screen, same story. The saturation curve first. MMLU climbs from random chance in 2020 to the high 80s by 2024, and then flatlines. Every new model lands on the same plateau. The dashed line marked humanish ceiling sits right under the cluster. The takeaway in one phrase on screen: when the line flattens, the benchmark is done. Switch to a harder one. Now the RAG 2x2. The horizontal axis is faithfulness. Did the generator stick to the source? The vertical axis is context recall. Did the retriever even fetch the source? Top right, both high, is the healthy quadrant. Bottom right is the trap: high faithfulness, low recall. The model is loyal to context it was never given, so it answers from memory and sounds confident. That is a retriever problem. Fix the chunking and the embeddings, not the prompt. Top left is the opposite. The right documents were retrieved, but the answer drifts off them. High recall, low faithfulness, a generator problem. Lower the temperature, tighten the prompt, add a self-check facts rail, one chart, and you know exactly which half of the system to go fix. Measuring is gate 1, and NVIDIA turns it into one API call, NeMo Evaluator, runs the same benchmarks and drag metrics as a job and hands you the numbers. But measuring tells you the model can misbehave. It doesn't stop it at runtime. Next, we wrap the model in a programmable filter that blocks the bad message before it ever reaches the user. Thanks for watching. Like and subscribe for more videos like this, and I'll see you in the next one.